Hey guys, Ethan Teach here, and I'm here to talk about surface area versus volume in your lungs. Now, one of the questions we had this week was which is more important and why? So let's discuss that a little bit here. So let's take this bucket. This is going to be our lungs. Now, this is an empty shell, which our lungs are not. But why aren't they? That was the question. So let's take a look at the first thing that the lungs have to do, and that is diffuse oxygen into and out of your bloodstream. So let's take a look at an excellent picture drawn of that. Here we have the sacs in your lung. Here we have the capillaries. Notice there has to be a gas exchange between the two. And the gas exchange cannot happen out in the middle of nowhere. It has to happen near a membrane right here on the edge of these alveoli. So if this was your lungs, if your lungs was just this open container, any air in the middle would not be able to interact with your bloodstream, not be able to diffuse with your bloodstream, so oxygen would not enter and CO2 would not leave, and therefore we would not be able to produce as much energy via aerobic respiration. So what would that mean for us? Well, it'd probably mean we'd be really, really slow organisms, probably have to be cold-blooded, a lot of things we could not be able to do. So luckily, what we do is we add extra membranes. Instead of just having one on the outside, we add more. So let's take a look at that. Let's say we added some very large spheres inside of our lungs. Now, we are definitely increasing our surface area, but we are decreasing our volume. Now, what's more important? Well, we said surface area is where diffusion occurs. Volume, unless we're going underwater, unless we're an aquatic mammal, volume is not as important because we have constant access to the atmosphere around us, except in some really weird scenarios, which you probably shouldn't be in anyways. So let's take a look. So we have very large spheres in here. This gives us a little bit more, maybe double, maybe triple our surface area, and our volume only goes down by a little bit. Okay, this is not going to help us. The actual surface area of our lungs is actually equal to the size of a tennis court. That's what it's always compared to, the size of a tennis court. If we took out all the surface area of these spheres, it would come nowhere near a tennis court. Okay, so we're gonna have to go smaller. So let's drop down a couple sizes here. Now let's imagine that these spheres are hollow. They're giving us a ton of surface area, and we're losing a little bit of volume, but that's okay because we need that surface area for diffusion of gases to occur. So now our surface area has gone up maybe 10 times what it originally was. Is that enough to keep us alive? No, because even if we unrolled these things out, they would not get anywhere close to the size of a tennis court. So we're going to have to keep going smaller still. And I'm at home and I don't have any supplies, so I don't really have anything to use. So let's take a look at a graph. The size of the air sacs, as they go down, notice the surface area begins to go up exponentially. So to get enough surface area folded into our thoracic cavity, enough surface area to cover a tennis court, how are we going to do that? Well, the air sacs have to be so tiny. How tiny are they? Well, the best way to think about it is there are 700 million inside of your thoracic cavity. So we're talking way down here, and that gives us an exponentially high surface area. There's another question about VO2 max versus lung capacity. I want you to really think about it. Some athletes do actually require lung volume, and lung volume is something you can increase. So if this is our lungs, you can theoretically increase the size of this through a lot of training. But for the average person, lung volume is not that important. This also might be called lung capacity or vital capacity of lungs, depending on who you're asked. But it is still important for a lot of sports to have high lung capacity. A great example of that is water polo. Now, they basically have to play volleyball while treading water. And also, swimmers are going to have a very high lung capacity. Ocean divers and stuff like that will have a high lung capacity due to their training. But this is one thing, you can't really increase surface area, but all humans, most humans, have an extremely high surface area in their lungs. Now about VO2 max. VO2 max is how much oxygen you can use. You are generally not limited by your lungs with respect to the amount of oxygen you can use. So that usually has to do with how in shape you are, how much mitochondria you have, and your blood flow. So keep that in mind when you're answering that question. Ethan Teach out.